Alright, so we're back this week. We're starting in on logic. This is something that's probably new to you, if not cool. If it is, don't worry. We're going to do a brief overview and intro, and we're going to practice it this week. Alright, so I'm actually going to split up the logic into two videos. The first one, we're going to do conjectures and counterexamples, so that's going to be part 1. And then the second video is going to be part 2. It's going to cover conditional statements, inverse, and converse. So the first thing we are going to start with is conjectures. And first off, what a conjecture is a statement that might be true. We don't know 100% if it's true, but there's a possibility of it being true. And if you're having trouble thinking of what a conjecture is, kind of think of it along the lines of an educated guess. Alright, so we're now going to go into some examples. I'm going to show you two of them, two different types that you're going to see here in geometry with us. Now the first example I'm giving you is that all shapes have two sides. Now if you know whether or not that's true, that's okay, that's a different story. But the conjecture here I'm making is that all shapes have two sides. And the second conjecture or statement I'm making is that if a number is a multiple of 7, then it is even. Now you're probably thinking about those statements and you're like, oh, I don't really know. But we're going to get into the next part, which is counterexamples, and it's kind of going to make a little bit more sense. So what a counterexample is, it's a specific example that makes a conjecture false. So those statements I made earlier, if you thought about something that like, oh, I know something that makes that false, that would be a counterexample. So for your counterexample examples, we're going to use those same conjectures we used. So the first one is that all shapes have two sides. And if you know your shapes, if you know anything of that sort, you know that's not true. Now, when you were thinking and you're like, wait, I know a shape that doesn't have two sides, that would be your counterexample. So your counterexample would actually be that shape you were thinking of. So in my mind, the first thing that comes to my head is a square because it has 4 sides. So for the conjecture, all shapes have two sides, a counterexample would be a square. We do not have to have the same counterexample though. Someone could have said a rectangle, a triangle, any other shape that does not have two sides, which there really aren't any, would be a counterexample. So you don't have to match with your partner, you don't have to match my counterexample, it just needs to prove the conjecture false. Now that second conjecture I gave you said, if a number is a multiple of 7, then it is even. So then of course your counterexample would be any multiple of 7 that is not even, that is an odd number. So when I think about 7, the first multiple I think about is either 7 times 1, which is 7, or another one could be 7 times 3, which equals 21. And since 21 is an odd number, 7 times 3, or 21, is a counterexample for this conjecture. So I do have two that I'm going to have you try on your own. The first one, the conjecture is all multiples of 11 are odd. So I'm asking you to give a counterexample or identify a counterexample for this conjecture. So the second one I want you to try is, the conjecture is if a number is multiplied by 5, then the product is even. So that is all for this first video. Today is just watching the 2 ed puzzles. There's not a separate assignment. You will get a scavenger hunt tomorrow. So make sure you do understand both parts of logic before tomorrow. Alright, so we're coming back for your second logic video. Remember, this is logic part 2. So remember, in that first video, I did cover conjectures and counterexamples. And so in this second video, I'm going to go over conditional statements, inverse, and converse. Now for your notes, today's video is a lot of writing on your tests and stuff. I'm not going to have you write them. They'll be provided. They'll be multiple choice. But please just bear with me for this video. So we're going to go ahead and jump straight in and start with conditional statements. The first thing I really need you to associate with conditional statements is this weird little statement below it. It says P arrow Q. You'll know what P and Q are in just a second. So you first need to know that a conditional statement is an if-then statement. So if this, then that. So here's where that P and Q come into play. So a conditional statement is written as if P, then Q. And you're probably like, what in the world are P and Q? And we're going to go over those now. So in conditional statements, P is the hypothesis and Q is the conclusion. So we are going to do two examples, and all I'm doing here is I'm labeling the hypothesis and the conclusion of the conditional statements. So the first conditional statement I'm giving you is if x is equal to -1, then 3x plus 6 equals 3. So I want to label the P and the Q here, the hypothesis and the conclusion. And remember, our conditional statements are written P arrow Q, which is if P, then Q. So with that being said, it's written if P arrow Q, which means the hypothesis comes right after the word if. So in this first conditional statement, x equals -1 is what comes right after if. So that means that's the P or the hypothesis. So then we know that after the word then in a conditional statement is the Q or the conclusion. So here, after then is 3x plus 6 equals 3. So that is our Q or the conclusion. So same thing here, I want to identify my hypothesis and my conclusion, the P and the Q. I'm just going to label them P and Q for this one. So remember, P comes right after the word if. So after if, we have 4 parentheses x plus 5 parentheses equals 3. So that's going to be our P. And then after the word then comes Q. So in this scenario, x equals 3 is our Q or the conclusion. So again, I am going to have you try too. So I want you to identify the hypothesis, P, and the conclusion, Q. You will have questions that pop up. So number 1, if 10 parentheses x plus 3 equals 100, then x equals 7. You're going to tell me the hypothesis and conclusion. And same thing for number 2, if x equals 12, then 2x plus 1 equals 25. So really important before you to get started, you need to know that the words if and then are not a part of the hypothesis or the conclusion. It's what comes after them. So we are going to jump into the inverse now. And remember, with conditional statements, we had P arrow Q. With the inverse, you have this little squiggly line, P arrow squiggly line Q. What you need to know is that this little mark stands for not. So the inverse is actually the negation of the conditional statement. That's where the not comes in. And so the inverse is actually written as if not P, then not Q. So we're going to jump straight into some examples. I'm going to write the conditional statement for each of them. I'm just going to abbreviate by conditional because we need to first label our P and our Q. So this conditional statement is actually the one we already used earlier in the video. If x is equal to -1, then 3x plus 6 equals 3. So we are going to go ahead and label our P and our Q. Remember, P comes right after the word if. So our hypothesis, or the P here, is x is equal to -1. Now the Q or the conclusion comes right after the word then. So the Q here is 3x plus 6 equals 3. So now we're going to get into writing our inverse. And remember, that inverse is not P, arrow, not Q. So it still starts off with if. But now we don't just put x equals -1. We actually go and we change it, and it's going to become x does not equal -1. Then, and same thing with our conclusion, since it's not Q, it's going to become 3x plus 6 does not equal 3. So now, instead of having P after if, you have not P. And then instead of having Q after then, you have not Q. So we are going to do a second example where I walk you through it before you try it on your own. So your conditional statement is if 4 parentheses x plus 5 equals 32, then x is equal to 3. And same thing here, we want to label our P and our Q first. So to label the P or the hypothesis, remember we look right after the word if. And we have 4 times all of this equals 32. So that is our P. And then we have to label our Q or our conclusion, and that's whatever is after the word then. So it is x equals 3. So that is our Q. Remember, we need to write our inverse now, and it's not P and not Q. So I still write the word if, and everything almost stays the same. So 4 parentheses x plus 5 close parentheses. Here's where it changes. Instead of that equal sign, remember it's does not equal. So the equal with the slash, 32. Then, and same thing here, instead of x equals 3, it's x does not equal 3. So just to get familiar with it, just to get in the habit, we're going to label our hypothesis or our P. And remember, this is not P. And same thing with the conclusion. It's now not Q. So the first one you're going to try, the conditional statement is if 10 parentheses x plus 3 equals 100, then x is equal to 7. And remember, I want you to identify, I want you to write the inverse. So your second example, the conditional statement is if x equals 12, then 2x plus 1 equals 25. So again, I want you to write the inverse for the conditional statement. So we're now going to jump into writing the converse of a conditional statement. We have our P's and Q's for conditional statement and inverse. So you also have one for the converse. And this one is written Q arrow P. So you need to know for the converse that you exchange or swap the hypothesis and conclusion of that original conditional statement. And your converse is written similar to the others. It's now if Q, then P. So remember, you want to look up here at this diagram if you get confused. So we're going to do the two examples again. It's still the same conditional statements. If x is equal to -1, then 3x plus 6 equals 3. So remember, I want you to write the converse from this. And that converse is Q arrow P. So up in the top like we have been, we're going to identify the P and the Q of the conditional statement. So remember, for conditional, P comes right after the word if. So our hypothesis, or the P here, is x equals -1. And then the conclusion comes after the word then. So the conclusion, or Q here, is 3x plus 6 equals 3. So for the converse, we're going to swap them. So we're first going to have the word if, but instead of having that hypothesis, we're now going to have the conclusion first. So if 3x plus 6 equals 3, then, and now we're going to have that hypothesis, then x equals -1. So remember, at the very end, we have the P, or the hypothesis, and now after the word if, we have Q, or the conclusion, and that's in the converse. So your second example, again, you're going to be given the conditional statement, and I'm asking you to write the converse. So we want to first label the P and the Q of the conditional. So if, and then you have 4x plus 5 equals 32 is our hypothesis, then our conclusion in this statement is x equals 3. So same thing, converse, we're going to swap the hypothesis and conclusion. So now we have if, and we bring that conclusion to the after the word if. So if x equals 3, then, and now our hypothesis is after the word then, 4 parentheses x plus 5 equals 32. So your hypothesis is now at the end, your conclusion is now at the beginning, and you've just written the converse for that conditional statement. So here are your two examples that you're going to try on your own. The first one, the conditional statement is if 10 parentheses x plus 3 equals 100, then x is equal to 7. So remember, I want you to write that converse, and it's Q arrow P. And then your second one is if x equals 12, then 2x plus 1 equals 25. Again, you're writing the converse. So before you do get started, it is really important to know that the inverse and converse are written from the conditional statement. They're not written from each other. So you always have to start off with that original conditional statement.